She didn't just run the experiment. She rewrote the rules of the universe. Chien-Shiung Wu shattered one of the most sacred beliefs in science, that nature is symmetrical. Her discovery changed quantum physics forever. It won her colleagues the Nobel Prize. But her name, left off the award, left out of the history books. This is the story of the woman who proved the universe was lopsided, and the world that tried to pretend she wasn't there. I was taught that the laws of physics were the same for everyone. I proved they were not. Chien-Shiung Wu, this is not just science, this is betrayal, brilliance, and the courage to be first. Before she changed quantum physics, before she challenged the symmetry of the universe, she was just a girl in a war-torn country who refused to be silent. She was born in 1912 in Liuhe, a small town in China. Her name was Chien-Shiung Wu. It meant courageous hero, and she lived up to it. At a time when most girls were denied education, her father, a progressive thinker and engineer, built a school just for girls from scratch. He believed in her. He gave her books when others gave daughters sewing needles. I was born in a time and place where girls were not expected to dream, she said. But I dreamed anyway. While other children memorized poems, Chien-Shiung devoured physics. She didn't want to recite answers. She wanted to understand why the earth spins, why atoms dance, why nature has rules. Physics wasn't a subject. It was a language, one that finally made sense. She would crouch for hours, copying Newton's Principia in neat Chinese characters. She studied by oil lamp. She built lab models out of scrap wood. She listened to the hum of electricity in the walls. When civil unrest reached their province, she wasn't afraid. She studied harder. She carried books through military checkpoints. She outscored every boy in her class. By age 11, she was already solving equations most adults couldn't read. Knowledge was my escape, not from my country, from the cage they tried to build around my mind. She had the mind of a physicist, but they treated her like the help. Chien-Shiung Wu wasn't just one of the smartest students at National Central University in China. She was the smartest. She graduated top of her class in 1934. She won scholarships. She stunned professors with her ability to solve quantum equations in her head. And when her country erupted into war, she made a decision that would change the history of physics. She left for America. New country, the same old ceiling. In 1936, Wu arrived in San Francisco with $20 in her pocket and an ocean between her and her family. She was accepted into UC Berkeley, where she studied under Ernest Lawrence, the man who would win the Nobel for inventing the cyclotron. But she couldn't attend official faculty dinners. She wasn't given a teaching assistantship. She wasn't even listed on department rosters, because she was a woman, an immigrant, unwelcome. "I did not come to make friends," she said. "I came to do the work." She poured herself into nuclear research, specializing in beta decay, the process by which radioactive atoms change their form. It was considered fringe, messy, and unsolved. Wu didn't care. She stayed late in the lab. She built her own equipment. She published papers, sometimes without her name even listed. I knew I was right. That was all that mattered. In 1944, she was recruited to join the Manhattan Project, the top-secret effort to build the atomic bomb. But while others were praised and promoted, she was kept out of meetings. Her calculations were used, her lab techniques copied, but her name still in the margins. She had helped split the atom, and they split the credit. It was not bitterness I felt, it was resolve. If they would not open the doors, I would work through the walls. Chien-Shiung Wu. Physics had rules, sacred, absolute, elegant rules. And one of the most sacred was this: the universe is symmetrical, that left and right behave the same, that parity is always conserved, even in quantum mechanics. But in 1956, two male physicists, Tsung-Dao Lee and Chen-Ning Yang, had a wild idea. What if parity wasn't conserved? What if nature wasn't symmetrical in all interactions? They had a theory, but no one could prove it. No one had the precision, the lab, the rigor, except Chien-Shiung Wu. She agreed to run the experiment, and not just run it, master it. She cooled cobalt-60 isotopes to near absolute zero. She aligned their nuclear spins. She built one of the most delicate experimental setups ever attempted in nuclear physics. And then, in the deep silence of the lab, she watched. The electrons didn't behave as expected. They preferred one direction. They broke symmetry. The universe was not balanced. It was one of the most shocking discoveries in the history of physics. It violated a fundamental law. It confirmed that weak nuclear forces do not conserve parity. It opened the door to quantum weirdness and changed how we understood particle interactions. She had proved it. Nature shows preference. The mirror does not reflect all. Chien-Shiung Wu. But when the world celebrated, it wasn't her name they shouted. In 1957, Li and Yang were awarded the Nobel Prize in Physics for the theory Wu had confirmed. She was not mentioned, not invited, not awarded, even though without her, the theory would have remained unproven. Their math was elegant, she said, but it was my hands that proved it. They gave the Nobel to the men. But Wu gave the next generation something greater. She gave them herself. After the experiment that rewrote quantum mechanics, Chien-Shiung Wu didn't disappear. She refused to. Instead, she kept teaching, publishing, lecturing, and breaking new ground in beta decay, weak interactions, and nuclear structure. She became the first woman president of the American Physical Society, the first female recipient of the Wolf Prize in Physics, the first woman to earn an honorary doctorate from Princeton, the very school that once barred her, but her proudest work, her students. She opened her lab to immigrant women, women of color, and first-generation scientists. The kind of minds that might have been dismissed like hers once was. I was told to sit quietly. She told them, "You will not be." She mentored with patience but no softness in her standards. She demanded rigor. She expected precision. She taught that science is not for those who seek praise. It is for those who seek truth. It is not enough to be right. You must be exact, especially if they don't want to hear you. Chien-Shiung Wu. She began speaking out more boldly, too. She denounced sexism in science. She criticized the lack of Asian women in faculty positions. She wrote op-eds and gave speeches on the hidden costs of invisibility. At a physics banquet in the late 1970s, she stood before a room of gray suits and said, "Why are there so few women in science? The answer is simple. We do not yet believe they belong." The room fell silent, and then it rose in applause. She'd once been the girl who studied alone by candlelight. Now she was the woman lighting torches for others. In the final years of her life, Chien-Shiung Wu did not slow down. She just spoke more clearly, more freely, more like a woman who knew she had nothing left to prove. She had broken one of the universe's oldest laws, and though the world tried to break her, it never could. She traveled, she lectured, she translated science into language young people could grasp and believe they could own. Her legacy was growing in lecture halls, in Daughters of Immigrants, in every researcher who learned about parity violation but hadn't yet heard her name. When Wu passed away in 1997, at the age of 84, the physics world paused. In China, she was honored with full state recognition, her ashes buried at the school her father once built for girls. In the United States, scientists and students quietly gathered to say goodbye. There was no Nobel, but there were whispers, louder now, of injustice and brilliance and the need to remember. It is shameful that we honor ideas but forget the hands that proved them. Chien-Shiung Wu. Today, the principles she confirmed govern neutrino physics, quantum field theory, the Standard Model, and even cosmology. Without Wu's experiment, the universe as we understand it would still be a lie of symmetry. Because of her, we know. The mirror does not reflect truth in weak nuclear force. Nature chooses sides, and truth, like parity, may not be balanced, but it still holds. The universe bent toward her vision. At Columbia University, a portrait of Wu now hangs in the same halls that once overlooked her. A crater on the moon is named in her honor. In recent years, textbooks have begun to correct their silence, listing her name beside Li and Yang, where it always should have been. "We lost decades of recognition," one physicist wrote, "but we gained a legacy of courage. She didn't seek the spotlight. She sought the truth. And when she found it, the world wasn't ready. But the universe was." Chien-Shiung Wu didn't just discover a flaw in physics. She revealed one in society. That brilliance wasn't always celebrated. That truth could be inconvenient. That not all names make it into the history books, but still shape the universe. She proved that the laws of nature are not always balanced, and neither is the world. But her life? Her life was the proof that imbalance can still lead to motion, to meaning, to change. I have always believed in the dignity of science, but more than that, I believe in the dignity of those who do it in silence. Chien-Shiung Wu. She shattered symmetry, and with it, every excuse to leave someone like her out. She measured the asymmetry of nature and taught us that what's fair isn't always equal. That being erased doesn't make you wrong. That even if the world forgets your name, the atoms remember. There is beauty in imbalance and power in those who persist when the world wants parity. Final quote overlay. If Chien-Shiung Wu's story moved you, share it. Tell your teachers, tell your daughters, tell your history books. Because the next time a young woman walks into a physics class and someone doubts her, they should remember the last time a woman was doubted. She rewrote the laws of the universe